Hi everyone, my name is Srikanth. I'm the co-founder and CEO of Fractal and have the real privilege of hosting Suresh Pillai from ProSiebensat today for this discussion. Hi Suresh.
Hi Srikanth, happy to be here.
Suresh, you are a theoretical physicist who accidentally got into the area of analytics, and then you've been leading the charge at ProSieben, building marketing attribution models for them. So tell me a little bit about your background. How did theoretical physics and analytics, how did that come together?
Yeah, I mean, I wouldn't say it's purely an accident. I mean, I'd say there's a bit of when you don't become fully successful academically, you find another route. After graduate work, I did graduate work in complexity studies and complex systems, right? So how systems composed of many components with simple rules can generate complex behavior at a higher level. And we can talk about that more later today because I have brought that along with me into analytics. So my first job was designing self-organizing routing algorithms for networks. This was at Nortel Networks at the time, very large global company. And also doing physics simulations. And then after that, I went on to distributed computing, which had a similar theme, right? So this is about, algorithms that are not centralized.
This was way before Hadoop came into place?
Long before, yeah. So, one of the early grid computing companies, which was Bicast out of Vancouver, working in the medical imaging space. Medical images were on film and collecting. And so they disrupted that field by, digitizing it and having a grid storage system. Physics was on complex systems, but of course, as we know, physics is a numeric degree, so we're used to algorithms and some statistics. We're not statisticians, but that conceptual thinking is there.
So, is physics really relevant for analytics? I mean, what from physics do you apply every day in the way we build probabilistic models and attribution models?
Right. I mean, I think the most important thing, it's cliched, is problem solving, right? Physicists are very good at problem solving. They're very good at distilling complex systems to the essential components. And when we build models in all sort of analytics, we're not building the full picture, right? We have to build concepts and think about what's important in describing the system.
Right.
And that's where physicists and scientists in general, chemists and even engineers are very good at doing that, right? That's what we're trained to do in our natural fields. I think that doesn't exist in computer science per se, right? So I think that's why, for example, I hire very diverse teams for my analytics departments, people with various backgrounds, because they all bring different viewpoint on any problem, right? A physicist, a chemist, a biologist, a computer science will view any system differently based on their training, right? We have different concepts. And they'll also view them at different granularities, right?
Yes.
If we go back to physics, chemistry, and biology, they are different levels, right?
Yes.
In some sense, they are dependent on the one below, but they're actually very separate.
Yes,
And this is a very subtle concept that even most scientists don't understand. The rules and laws of biology are fundamental in themselves at that level.
Yes.
Right? You cannot always just calculate them by doing chemistry, right?
Absolutely.
So they arise at that level. So physics, chemistry, biology, and so on have fundamental rules in themselves at each level.
So if you look at, going on to, taking that cue, physics tries to explain, and we try to explain like Newton's law, you're trying to explain through a fundamental law. Whereas mostly in the world of analytics, you're not trying to really explain as much as trying to understand patterns and get slightly better than random.
Right.
As opposed to physics, where you're trying to explain and basically get perfect answer to a problem. So does that bother you? Is that because analytics is not evolved yet, or do you think?
Yeah, I think it's more the latter, right?
Yeah.
So, as you said, analytics is really about prediction, right? Can you predict better than random?
Yeah.
And so that can be black box, because if you do tests and you say your prediction is good, you're happy, right? But science is about understanding, right? It's about generating concepts and advancing theory, so it's progressing. And I think that's the big difference between analytics and science is evolving and progressing its models and its theories. In analytics, we're evolving our methods, but we're not evolving our understanding, right? And we know, and especially now with deep learning, right? It's very black box, right? To actually then take that and give an understanding to your business partner is a challenge.
Yes.
But you don't have to go to deep learning. You could go even to nonlinear models, right? If there's a linear model, and this is the definition of linear, is you can break it up, right? You can say A plus B equals, the sum. But nonlinear, we can't do that, right? So if you have a complex GAM model, for example, which is what we're using in our marketing mix models, at ProSiebenSat.1 with obviously the help of Fractal. When I get a final number for the contribution from the different channels, or even just from TV itself on different days, how do I say how much came from the first day, the second day, and third day? Because I have one number which had a nonlinear curve, right? So I can't say, oh, one day had the nice part of the curve, the next day had the steep part of the curve, and so on, right? So it's actually impossible, right? Even for a non-black box model, I can't break it up, right? And this is the difference between linear and nonlinear. There's one about having meaning and explainability, whereas analytics at present doesn't strive to necessarily do that. Right?
And if you see the advances in deep learning right now, I mean, we are probably going in the other direction. In fact, even if you look at this most simplest statistical model, they had explanatory power, as you could at least explain to other people. Now with deep learning, it's harder and harder to explain. So in some ways, do you see that the world is just getting away from explaining and actually having a more sound conceptual causality models that physics provides?
I think so, and that's what I try to influence the direction another way, right? I mean, deep learning does have some fundamental scientific concepts in it, and it's exactly what we talked about. I just talked about physics, chemistry, biology being different scales. What deep learning does is build a model at different granularities, right? That's what made it, one of the parts that made it successful, and that's easiest to understand in image recognition. Right, it tries to determine fine details first, and then it scales up to more abstract concepts, right? And we think that's what our brain does, but I'm not an expert in neuroscience.
So is it just performance? I mean, we are showing that deep learning is performing way better than other techniques in many different problems, especially when there's unstructured data, and even in some of the very structured data problems like marketing mix. So if we had a attribution model which is based on deep learning and it's performing way better than, let's say, a more conceptually sound model, which would you pick?
I think it depends on what you need to do. I mean, for example, if you're building a model, attribution, and again, attribution, when I speak externally, I talk about the different levels of attribution. So as you can see, I have a big theme, because an attribution model, if your goal is to explain to finance how to determine the budget, then you don't really care about the fine details, right? You just have big chunk numbers. This one goes to channel A, this one goes to channel B. And you can do some highly average numbers to determine that model, right? And the extreme is, do I need to target, personalize, or do I need to price for programmatic, right? Then I need an atomic, multi-channel attribution model, which needs to understand the value of every impression and click. In the middle, so I usually use 3 levels. We have historical, cultural 3 as a big number, but it's also easy to understand. In the middle are the marketing department, and you need to give the marketing department some intuition and some tactics of how to deal with their different channels, right? Should I target this customer with this channel? What happens if this customer comes through channel A first and then follows channel B? Where are those patterns, right? That's something that needs to be explained. And if you can't get that, let's say, I mean, I haven't done any deep learning on attribution models yet, but let's say you had some really successful deep learning atomic level attribution model. Now, how do I explain the insights to the marketeer, right? I can't. So in that case, that model would be useless to me.
This has been, let's say, my experience 15, 16 years ago, trying to explain neural networks or use neural networks, and there would be significant pushback from the business users saying, I can't understand them, I won't use a black box. It seems that has changed now. I mean, people are beginning to embrace these kinds of models because they're performing better, and at the end of the day, if your dollar is working harder using deep learning, you would probably use that. So
it depends if you're being algorithmic or are you being business insights, right? And these are 2 different avenues of analytics, right? If I'm trying to build a great AI algorithm and I care more about the result, then of course, a black box algorithm is fine. If I need to determine recommendations to give to the marketing department or the finance department, then I do need some insights, right? And in that case, either you need to extract some meaning from your model, and there are ways to do that, or you build a different model, right? As I said, you need to build a model at a higher level, right? A different model.
Right. Let's talk a little bit more about marketing mix. I know it's your, marketing mix and attribution are your favorite topics. And we know that the world of advertising is changing quite dramatically. The overall spends on digital are going to exceed TV spends this year. And that's a far more accountable kind of a spend, and we have more granular data there. In that world, how important is attribution, and are companies really paying as much attention as they should around getting more scientific models around attribution?
Yeah, I mean, what's always surprised me is that people continue to use the old school last click models or similar models, which we know typically in most cases are incorrect. At my time at eBay, and I've spoken externally many times, we showed these simple toy models, last click, first click, first click
Average.
plus last click, or all clicks, and you can put whatever weightings. You can imagine all the possible, and I call them toy models. You can have them decaying back in time, exponentially, power law, whatever you want. When we looked at all those models, they all gave the same final attribution, which is an amazing result. But more amazing is they gave the same value as a random attribution. So it shows you all those models are useless. But people still continue to use that. I mean, it's the default if you're using Google Analytics and so on. So I would believe people are making decisions incorrectly on their marketing mix if they're doing atomic attribution modeling for online marketing. So we really need to move to more sophisticated attribution modelings. If you think about these toy models, I mean, let's step back, and I think this has been a failure in the industry. Why would we think that last click always has the same value for any purchase journey, right? I mean, that doesn't make any sense, right? And so the main problem here is if you step back, people looked for patterns because we love doing patterns in analytics, and they look for patterns just purely on the channels. So saying that this channel, then that channel always has some value, and that doesn't make sense, right? It's a different customer every time. You have different intent every time. 1 week, the first Google search may have been the important motivating factor, right? Next time it could be the last Google search. So why would you expect it always to be in one slot? So if you actually step back and think about it, it's actually obvious that these models are wrong. So what you then move to is dynamic models, right? Every time a customer visits, you need to have a model that evaluates what's the value of this customer right now, and that's obviously what you need to do proper programmatic bidding, right? You need to determine what's the value of this impression or click. So it's dynamic model. So you need some function that you update, and without giving away the secret sauce, obviously one obvious way is to every time a customer visits, calculate the probability of them to purchase an item in next X days. I mean, let's give that one away, right? So we need to move to dynamic attribution models. You need to have some update function, and then you need to put all those values you see in the path of the updated function and say, all right, what's the value I attribute to each of those touch points? So I think the industry is going to be forced into this now as programmatic becomes more prevalent. And I think, as you said, marketing spend becomes bigger and online, maybe people will notice that there's something wrong with their attribution model.
And I just want to get your sense between the toy model, for example, if I was using a toy model versus a very sophisticated model that you're saying, what's the difference in terms of performance? What are we talking, hundreds of millions of dollars, or what percentage of ad spend can you get more out of? What is the ROI increment that you get?
I think as I said, the toy models are the same as random. So you're not actually doing anything, right? You might as well get rid of all your analysts, replace them with monkeys.
How better are we vis-a-vis random when we use a very sophisticated model? I mean, let's say I'm spending $100 million on my ad spends, and today I'm getting a certain amount of efficacy of those ad spends. And if I used a more effective way of doing these ads based on more scientific attribution models, what incremental lift?
That's a difficult question. I think it depends on the business model and the size of the business, right? And how many channels. But I think I think it can be as large as a 30% variation, right? Okay,
so I mean, just to take an example, let's say my current click-through rate is X on my ads, and if I did a better job, it will be much higher, or cost will be 70 cents for the same number of clicks?
I think it's going to be a mix of both the performance and the number of conversions you're getting, but I think it's really more about the cost efficiency of your whole budget.
Got it. Yeah. Got it. And are you using any physics here, or is it?
I'm not using any physics there, other than, we talked about these multiple levels. So I think the insight there is most people would say, all right, let's build the completely atomic level model, and then I average it up to get the marketing understanding, then I average it up again to get the finance understanding.
Sure.
You can definitely, if you have a dynamic model and you have all your data for the past year, you can definitely average over all the clicks and say what's the value of each channel, right?
Yes.
But you may not necessarily be able to tell the marketeers any specific insights, right? Because there may be too much noise. There may actually be no patterns, right? In that case, I would say you might have to build a different model.
Right. So most people are still not spending all their money online. They're spending a very good mix of their money on TV and then some on digital and so on.
And that's my current role.
Right.
I work for a large TV media company in Germany. So there, it's very important for us to understand what's the impact of TV, but it's not TV in isolation. Usually when you as you know, with some projects on this, there's online marketing, and then there's the TV, and then there's offline. They have different models, right? And that's not very useful, right? And specifically in our case at ProSieben Sat.1, where we have a whole portfolio of digital assets, and we're using TV marketing to drive traffic and revenue, obviously, to these assets, and these are online assets, right? So it's a mix. So you need to build a model that combines both offline and online.
Right. In doing that, is it, do you suggest, or do you think it's a good idea to actually have a solid consumer level understanding and ground up, and even simulate from there and get there, or do you think it should be more top down, or is it a good mix of both?
I think it's a mix of both, and there's many reasons. One is just for how easy it is to do. Top down, as we know, traditionally marketing mix models are a bit more straightforward, right? So if you want a first view of what's going on, you can build a top-down model, including online, right? So, and that's what we've done. And that'll give you an understanding of the relative performance factors of the different channels. Now, eventually you do want a bottom-up attribution model. And the trick there, for example, with offline and TV, it's not tracked, right? So how do you feed it in, right? I mean, online is fully tracked. So you need to do some tricks there. And we're doing some there. I mean, we're using some predictive modeling to identify TV customers. That's one thing. But I think moving forward, let's say you're at the stage, you have a top-down model and you also have a bottom-up model.
Sure.
I think the next step for those people who actually have a good attribution model, once you've reached that point, is to actually mix the two. And this is a very statistically and scientifically difficult problem, right? How do I mix models at two different granularities? And I think that's really the next step in marketing analytics.
So to get that mixing, do you have a consumer level simulation model which looks at
you have a high-level long-trend model, right? And high-level long-trend models are good in their case because there's some data you can't really put in a low-level model, like
yes.
market trends
yes.
And external influences. You cannot put that in an atomic model. And that's one reason you would really want it. If you have a good attribution model, how do I bring the high-level economic trend data into that model? And so you have to merge it, and I think that's an open challenge statistically.
You moved from a very sort of data-savvy organization like eBay to a more traditional organization like ProSieben. How have you transformed this organization? How are you transforming this organization to be more analytically savvy?
Yeah, I mean, that's a very good question. I mean, obviously ProSieben hired me, so they recognized the need to be more data-driven. But I mean, it's a cultural shift, and you hear that, but it's truly in that sense, because if you're not used to someone giving you a number and not really grasping where that number came from, I mean, trust needs to be built. So I think what's been important for me is to build trust with the leadership, that they can trust me, but also the whole concept of modeling and giving numbers to that summarize some sort of activity. So it's building trust in one direction. Obviously the people who use these numbers are eager to get them because it enables them to make decisions faster and more data-based, obviously. But then you have to temper that eagerness. I always say you have to be skeptical about models, right? You have a finite set of data, and we should all accept there can be an infinite number of models on that finite set of data, right? And our job is to find the right model that fits the system. And there's a lot of business input in addition to the statistical input. So what I've just said are actually two opposite things, right? I'm trying to build trust one way, I'm trying to build healthy skepticism the other way on the same system. So I think that's been the challenge for me, to say the right thing so that both are understood.
And part of this is also about hiring a set of people that can do that with the rest of the organization, right? So how have you built that team, and what kind of people do you look for when you hire?
So this harkens back to what I said earlier. I build diverse teams, right? So I don't just build teams built of cookie-cut data scientists from the programs that you see now, or people who've come only through computer science. A diverse teams, physicists, electrical engineers, economists, finance, and of course the computer
And many
science.
of them are not really used to being trusted advisors of CEOs or top leaders. So how do you build that capability of advocacy and earning trust, and also a healthy skepticism, which probably they get because of the science background that they come from?
Yeah, I mean, communication is very important, and let's be open, people from these fields aren't traditionally known to be strong communicators. So I think there's two types of coaching going on. One is what I talked about, the problem solving, scientific coaching. In terms of hardcore data science skills, most people are going to build that up themselves. That's out there in the open. So it's really that how to problem solve, and the other one is really how to communicate. And communication is important, right? Because if you can't communicate what you're doing, then most likely you probably don't understand what you're doing deeply, right? I am a strong believer in that. If you can stand up and present what you're doing, whether you're a teacher, a professor, or a presenter like we always do, I mean, you can judge, I think, immediately. Someone who understands what they're saying is probably someone who understands what they're doing. So communication actually feeds back onto their skills as a data scientist.
Right. And certainly, do you see the CEOs and the leaders of the organization that you work with, do you see their interest in understanding the science behind data science these days, or they still just want results? What are the kinds of leaders that you have seen in your experience?
I think it depends on the individual. I've seen both. I think there is a curiosity to understand what's going on under the hood, especially if you've not exposed to that before. It depends on your background. But if you already have a faith in analytical and scientific methods, then I think it's more about getting the insights. But in the end, at the C level, it really is about the insights, right? The insights, the recommendation. They have to make quick decisions. Our job is to summarize a lot of data into a few KPIs or a few, very strong insights for them to make that decision.
And you've worked for both North American companies and European companies, and you've worked for eBay in Europe and ProSieb in Europe, yeah. And before that, online poker and grid computing in North America. Do you see any major difference in terms of evolution of analytics or acceptance of analytics between the two continents, or are they fairly similar at this point of time?
Well, I think North America was definitely ahead of the game, right? I mean, when I was working for online poker company, that was back in 1995, before I think all the terminology we use today didn't even exist. So there was obviously a very savvy company and its leadership who recognized they need a strong business intelligence analytics team. And I think North America as a whole has been more data-driven earlier. And Europe is catching up a bit, but they're catching up very fast. There's been a very strong recognition of the need to really infuse data and analytics throughout the enterprise.
One of the scary as well as the interesting thing about analytics is the reality of something like a Minority Report, where all of us are continuously tracked. Everybody understands our behavior and are able to target advertising and marketing specific to our needs. So this is somewhere coming together of customer analytics and marketing attribution. How far are we from such a world?
So I mean, marketing attribution is typically associated with performance analytics, and customer analytics is about personalization and targeting, as you said. But they're very much highly related. I talked about earlier about if you have an atomic level attribution model, you can use that for programmatic bidding, but you can also use it for personalization and targeting, because when someone visits your site, and if you have this dynamically updated attribution model that gives you, say, for example, the probability to convert, then you have a strong piece of information of how to interact with them, right? And you can take it further, because you can not just have this updated function, you can also have some associated models about intent, right? When they visit your site, what is their intent? Are they there to just browse, or are they there to buy, and are they already decided? And based on that, then you can target your communication. So here you have a model that's being updated that can give you, the value of marketing to that customer, but the value is also telling you, what sort of communication you should give to them.
Right. There are positive feedback loops in something like this, right? In the sense that you expect a consumer to behave a certain way, and then you influence the same behavior by, let's say, placing an ad or recommending something, and then they end up behaving like that. For example, bestsellers are bestsellers because they're bestsellers, right? Yeah. Because they're bestsellers and they're on the best-selling list, more people buy it. Yeah. So there is do you see dangers of not having true understanding, because we're already incorporating what we know or what we expect to know and actually positively influencing behavior? How do we sort of break that out and test scientifically as to what's really going on and what is the true incremental impact and whether our knowledge is correct?
Well, you can run tests, right? You can definitely do that. In terms of this targeting, it's not really, you know, a promotional targeting. It's right. It's understanding where they are in their journey, right? So I think it's a bit different, right? If you have a good model, when someone visits your site, and here again I'll go back to my 3 levels, right? You can have them looking at 1 or 2 items. So there's a journey for them. Are they going to buy that item in the next 10 days? But you also have a lot of, you know, analytics on, okay, are they always buying in this category, and you'll know their journey through that category, and you'll know their journey with you as a customer just in general, right? Are they a loyal customer? Are they a new customer, and so on? So you have these different levels again, and the question is, and you'll probably have models at different levels, and the question is, if you want to make a decision on how to interact with that customer in terms of targeting or next best action, which model do you use, right? And that's, I think, the challenge, the big challenge in attribution and customer analytics is you have different models. They're in different verticals, but they're also on different levels. Can you combine them all into one single decision of how you interact with the customer? And I think here, this may be some case where deep learning may actually be used in customer analytics. I think most people would be surprised to hear that. If we go back to deep learning, what we're saying is deep learning inherently has within it models at different levels, right? It goes up from atomic to coarse-grained features. So maybe we can use that to understand how to understand a customer at different levels as well. The other feature of deep learning is it can propagate signals, low signals over long space and long time. And as we know, really the biggest thing in customer analytics is understanding really what's the CLV, what's the long-term path of that customer with you. And so I believe deep learning may provide something here, whereas most of our models are local, right? And we can give a local prediction and a local reaction. We don't really at present have models that properly understand path in the long future. As we've seen with some of the demos recently, especially Li Deng was showing from Microsoft, right? He was showing in the breakout game, first a local optimization, which you're trying to hit as many blocks as you can, and the obvious algorithm to hit many blocks is just to keep hitting all the little blocks until you remove them. But for those of us who did play Breakout in the 80s, I think not everyone here is necessarily old enough, the real strategy is to dig a hole so that it goes up top and then keeps on banging and removing blocks. And we've seen how deep learning algorithm can do that. And that's the same thing as customer analytics. That's the CLV, right? Rather than optimizing short term, can I find that path along these, almost infinite number of paths the customer can take with you, depending on which purchase and how many visits? Can I find that nice optimized path to the end? And I think that's where deep learning will actually start influencing our models in customer analytics.
So do you think that's the future of marketing analytics?
I think so. I think we now have a whole set of tools. I'm cautioning against deep learning isn't going to be everything. There's still value in logistic regression and random forests and so on. Different types of questions determine different types of problems. But I think deep learning is now, as I said, we've never been able to model these small signals that die out in time, right? And that's why calculating CLV or calculating a next best action that determines long-term loyalty has always been difficult for analytics. I think deep learning may be one method that may help us solve that.
Right. As a consumer, do you find this exciting or scary as a consumer?
Let's always be honest, it's both, right? I think individuals don't like being tracked, but I'm in the business. I get very good advertising targeted at me now because we're out there on Google and Facebook and so on. So I find that very useful. But I think there's always limits, right? And that depends on the culture and the individual. And I think most people know, especially global companies, you have to behave differently in different countries, right? Not just according to the laws, but understanding the culture and what people are sensitive to. In the end, it's an agreement between the customer and the company. We give them data and we expect a service back from that data, right? And that's useful advertising rather than, broadcast advertising. And so, yeah.
Given how important marketing is, and I understand the importance of analytics in marketing, but there are so many other bigger, let's say, problems of saving the world, like healthcare and so on. Do you feel that too much of our talent is going into doing financial engineering or improving the effectiveness of marketing, as opposed to doing, let's say, more fundamental things like, saving lives?
I think this is one of these cases, what we learn even in, finance and marketing, which I think are still useful for us, those techniques get propagated to the other fields. So we see now, for example, I know you guys are doing some incredible deep learning on medical imagery for cancer diagnosis. People are always been involved in all fields, right? It's people are driven by different things. Analysts like finding cool algorithms and cool results, no matter where they are. But of course, usually they do benefit all fields overall. What happens is it's naturally where the data is, right? And so most data in the past 5 to 10 years has been in finance and in marketing. And that's been the greatest push, right? Because that's where we could be the most successful. But now we see those ideas and those models moving to healthcare and to other fields, also to insurance and so on. And there it's about making it more efficient for both parties, right? Both the provider and the customer, and that's in the benefit of everyone.
Thank you, Suresh. It's been fascinating chatting with you about deep learning, about marketing attribution, and the future of marketing and customer analytics. Thank you.
Thank you, Srikanth. Always a pleasure.
Thank you.